The solubility of a solution can also be described qualitatively as unsaturated, saturated, or supersaturated. In a saturated solution, the solution contains the maximum amount of dissolved solute allowed at that temperature. Unsaturated solutions contain less than the maximum solubility at that temperature, and supersaturated solutions contain more. In a saturated solution, undissolved solute and dissolved solute are in a dynamic equilibrium. In an unsaturated solution, any new solute will dissolve, whereas in a supersaturated solution, the amount of undissolved solute is growing over the solubility limit. Supersaturated solutions can be created by heating the solution, then adding more solute, and then slowly cooling it down. A solubility curve shows how much solute can dissolve in a certain amount of solvent at a given temperature. So this is the solubility of potassium nitrate, KNO3, and you can see as the temperature increases from 0 to 120, the curve also increases, okay? So we would say here that at 100 degrees Celsius, the solubility of potassium nitrate would be 250 grams in 100 milliliters of water, right? Anything below that would be, so if I only put 150 grams in at 100 degrees Celsius, that would be an unsaturated solution. And if I tried to put more, say up here I tried to put 300 grams in 100 mils of water at 100 degrees Celsius, that would be a supersaturated solution. The solubility curve for salts is difficult to predict. So you can see here that in green we have Ce2SeO3. This salt right here. You can see it's not constant, right? It decreases, 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 right? So they're not as smooth. Whereas the solubility curves for gases clearly show the inverse relationship of gas solubility and temperature. So as the temperature increases, the solubility decreases. The solubility of a gas doesn't just depend on temperature, it also depends on pressure. So the higher the pressure above the liquid, the greater the solubility. So if you had a sample, right, and you had, let's say, water, and then you had some gas bubbles dissolved in it, and then you also had some gas sitting on top of it. So you have some undissolved gas sitting on top of the liquid, some dissolved gas inside the liquid. If you increase the pressure here, you're going to force more of these gas molecules into the liquid. Okay? So if the partial pressure of the undissolved gas is increased above a liquid, the equilibrium will shift and more gas will dissolve. This is how soft drink manufacturers carbonate your soda. They crank up the partial pressure of the CO2 above the liquid, and that causes more CO2 to dissolve in the liquid. Then they seal it with a lid on top so that that high pressure is maintained.